Good day everyone. Welcome back to the Azure Databricks series. In today's video, we are diving into a powerful technique to boost your query performance, partitioning in Azure Databricks. We will walk you through a step-by-step guide where I will show you when to use partitioning in your data pipelines, how it can drastically improve performance, and what challenges or pitfalls you need to watch out for as your data grows. This isn't just theory. We will be getting hands-on with a real demo so you can see exactly how to implement it the right way. If you're working with large data sets in Databricks or just looking into fine-tuning your query speeds, you don't want to miss this. If you find this content helpful, give it a like and don't forget to subscribe to the channel for more in-depth Databricks tutorial. All right, let's jump in and get started with partitioning. So for this particular demo, I'm going to use two tables. We will use two tables for this demo. Yeah, the first table is sales underscore data. Yeah, it's just a simple delta table. If you look at it, we have this many columns for the sales underscore data. Okay, and the second table would be sales underscore data underscore partition. It has the same number of columns, the same number of data types. The only difference is like we are partitioning this table on the transaction underscore date column. Yeah, so this demo will be based on these two tables. Yeah, so what I will be doing is like I'll be executing same set of queries on sales underscore data and then on sales underscore data underscore partition, and we will discuss about the performance of each of these queries that is going to run on each of these two tables. Yeah, so first what I'm going to do is like let's look at the number of rows we have on each of these two tables. Yeah, okay, if you see here, we have close to like 6 million rows on sales underscore data and sales underscore data underscore partition. If you see here, sales underscore data underscore partition has got more rows when compared to sales underscore data. Yep. So now what I'm going to do is like I'm going to look at the table structure for each of these tables. Yeah. So what I'm going to do, I'm going to first look at the number of files. Yeah, so I'll be concentrating on partition columns and number of files here. This is for the sales underscore data, is simple delta table, and let's look at this partition table as well. Yeah, if you see here, the partition column here is transaction date that we know already. But if you look at the number of files here, yeah, for the sales underscore data, I'm able to see like there is close to like 300,000 rows, 300,000 Parquet files, yeah, but the number of files for partitioned table is just 61, yeah, and size in bytes is kind of same. Like if you see here, the sales underscore data partition table is comparably, the size is comparably high. Yeah. Now what I'm going to do is like I'm going to look at these two tables under catalog, and then we will take it from there. Okay, so if you see here, I'm looking at the details of sales underscore data. Yep, and if you see here, the size is close to 3 GB. Yeah, and I have close to like 300,000 files. Yeah, and if I further go into details, I'm able to see like the storage location is this one. Yeah, so now what I'm going to do is like I'm going to get into the storage location and then just look at the files. Yeah, so the table location is here. It is 0C7. So let's go there. So I'm going into this West US2 Metastore because that's what I'm seeing here. Yeah. So let's go there. And if you go to the tables, we have this table 0C7FF004. Yeah. And what I'm seeing is like this is what I'm seeing here, 0C7FF004. So this is the folder that has all my files for the sales underscore data delta table. Yeah. So if you see here, I'm just seeing the Parquet files directly. Yeah, that is what I'm seeing here. So now what I'm going to do is like, let's go to our partition table, which is sales underscore data underscore partition. And what I'm seeing here is like we have close to like 61 files and the size is like 337 MB. So if we look at the data again here, what I'm seeing is like the number of rows that I have in the partitioned table is close to 6 million, yeah, slightly greater than the data that is present in the sales underscore data. Yep, but what I'm seeing is like sales underscore data is close to 3 GB and sales underscore data underscore partition is close to 337 MB. Yep. So what I've done is like basically like I've created these two tables and then I've inserted the required row into each of these tables. Yeah, and what I'm seeing is like as soon as I've inserted the row, what I'm able to see is like the number of files seems to be very, very high on the sales underscore data table. But on the other hand, sales underscore data underscore partitioned seems to be like comparably great. Yeah, it's like just 61 files. Yeah, maybe like we had more operations on the sales underscore data. That's the reason we have a lot of small Parquet files created, but partitioned table maybe like we did not have much of an workload there, so it's sitting at 61 files. Yeah, let's look at the details here. Yeah, and then what I'm able to see is like as far as the partition table is concerned, the location is this one. Yeah, so the whole location is this one. So let's go into that storage location here and then let's look for that particular folder. Yeah. So if you see here, it basically starts with EBC4. Yeah. So let's go to EBC4. I think this is the one. And if you see here, what I'm able to see is like I'm able to see that each and every file is placed into onto a folder based on the partition key. Yeah. Now, if I execute this particular command, which basically gives me information on the partition, yeah, that will give us more details. Like for example, these are the uh, partitions that are created for this particular table, sales underscore data underscore partition. And with the number of partitions here, yeah, what I'm able to see is like those partitions are basically covered here as the folder here. Yeah, I'm not able to move this off. Yeah, so I'm not able to show you guys, but if I click on that, click on one of the table, then what you can see is like you can see that it is transaction date 1 January 2024. And if I see here, I'm able to get that one here. Yep. So you will have that particular data here. Yeah, so what is happening is like based on the partition that is created, for each partition, Databricks creates a folder and then moves the required Parquet files. Now, when we do additional operations on this particular table, like for example, you add more data, remove some data, update data, what happens is like the Parquet files within each of these folders can increase, yeah, and that can lead to some performance issue. But right now what I'm seeing is like we have this many partitions and we are going to execute the queries further. But what I feel is like with the sales underscore data partitioned table, I'm just seeing 61 files. Yeah, but if you look at the sales underscore data, it's close to like 300,000. So what I would suggest here is like it wouldn't be a proper comparison. So what I'm gonna do, I'm going to basically run the optimize command on each of these particular tables, yeah, and then I'm going to check that further, yeah. So what I'm going to do first, let me run the optimize command for sales data, and then I will run the optimize command on the sales underscore data underscore partition. So once this is done, what I'll do is like I will look at the number of files, And this would clearly tell us like what would be the file, yeah, because previously the sales underscore data had close to 300,000 and the partition table just had 61 tables. So now after running the optimize, let's look at the details like how many files we have, and that would tell us like which one is kind of better. Like for example, if I see more files in one of these things, then having more files is going to take its own time to traverse through all these files and get the data. So going to take some time. So let's complete the optimize and then we will move on with other queries. So the optimize command is complete now. Yeah. For sales underscore data, it took close to like 16 minutes, and for sales underscore data partition, it took close to like 6 seconds. We know like why it took so much time for sales underscore data, because we had close to like 300,000 rows to be 3,100 Parquet files to be processed. Yeah. So now what I'll do is like I will run this describe detail now for each of these table. Yeah. And if you see here for sales underscore data, I'm able to see close to like 49 files. Yep. And for sales underscore data partition, if you can see here, the partition column is transaction date and the number of files is 61. So if you see here, sales underscore data underscore partitioned table has got more files now when compared to sales underscore data. Yeah. Now what we'll do is like let's look at the sales underscore data underscore partition, and if you can see here, it is 61 files and 337 MB. On the other hand, sales underscore data is like 329 MB and 49 files. Yeah. So it's time for us to execute different queries and then compare the performance. Yeah. So now I'm going to first start with this particular query where I'm querying the sales underscore data table. Yeah. And I'm basically checking for 1 year data. Yeah, 1 January 2024 and 31 December 2024. Yeah, so the predicate is on transaction date. I'm grouping it here using the transaction date. Let's execute this query, and also this particular second query, which is on the partitioned table. We have the same query here. The only difference is like this particular table name. Yeah, here we have sales underscore data, and here we have sales underscore data underscore partition. So what you'll do, let's execute it and then let's compare the performance for each of these queries. Okay, so the query is completed. Yeah. So this query took close to like 29 seconds when we executed this query on the sales underscore data table. Same query, we executed on sales underscore data partition. And what I'm seeing is like it completed within 22 seconds. Yeah. So we are able to save close to like 6 seconds as far as the partition table is concerned. Yeah. So now what I'm going to do is like I'm going to execute a different query. First on sales underscore data, and then the second query is on sales underscore data partition. The query is same. So basically what I'm doing is like I'm again having a predicate for 1 year. Yep, and doing a group by, but the aggregation that I'm using for the second query is little high when compared to the first query. Yeah, so this query on sales underscore data took close to like 18 seconds. Yeah, 18.16. And then when you look at the execution time for the second query, it is 9 seconds. Yeah, so the query on the partition table is like 1x faster when compared to the same query running on the sales underscore data. So this proves like if you look at these two queries, yeah, what I can understand is like the partition table is definitely performing really better when compared to the query executing on a normal delta table. Yeah. So now what I'm basically doing is like I'm executing it for 1 year. Yeah. So now what I'm going to do is like I'm going to try eliminating some partitions. Yeah. So let's check this information first. What I'm basically doing is like I'm looking at the number of data. Yeah. So number of rows that is there for Jan 2024, February 2024, and March 2024. Yeah, if you see here, more or less it is same. Yeah, so the first one has got 3 million rows. January 2024 has got 3 million rows here as well. And February it is 2.9 million, and here also it is 2.9 million. And March it is like around 100,000. Yeah. So now what I'm going to do is like I'm going to run this query, but this time I'm not going to use 1 year data. Instead, I'm going to just going to query only the data for 31 days around on January 2024. Yeah, here I have sales data. Yep, and here I have sales underscore data underscore partition. So now let's compare. Like now, if we are just querying for 1 month data, and we should be having some of the partitions getting eliminated. So let's look at the comparison, and then let's take it from there. Okay, so the query completed. Yeah. So it took close to like 13 seconds for this query on sales underscore data, but the same query on the partition table is close to like 3 seconds. Like what I'm seeing is like this query on the partition table is like performing 4 times better. Yeah, it's 4x performance improvement. Yeah. So now what I'm going to do is like let's kind of use a non-partitioned column in the uh, predicate. Yeah. So here what I'm going to do is like I'm not going to use the transaction date. Yeah. So we know that this particular partition table, we have the partition column on transaction underscore date. So now what I'm going to do is like I'm going to use the predicate as unit underscore price. Now what happens with this query is like this one is going to scan through all the Parquet files, yeah. But this particular query, it has to now scan through all the partitions. So let's compare the performance and then see which one performs better. Let's give it like a couple of more minutes and then see what happens. Now, if you see here, the query is completed. So this particular query having a predicate on unit underscore price when run on sales underscore data took close to like 22 seconds, yeah, 22.45 seconds. But the same query on the partition table took close to 15 seconds. Yeah. So even when we used an predicate that is not your partition column, what I'm seeing is like the partition table seems to be performing well uh, uh, than the normal delta table. Yeah, that's what I'm seeing. Now the thing is like, let's see, we have partitioned a table. Yeah, and in case if we have a lot of queries or the workload that is coming into this delta table is greatly changed, where it's no longer using or the number of times the predicate using the partition column has come down considerably, then there is a problem in that. Yeah, because what happens is like when you use a non-partition column as the predicate, there is high possibility you will lose that power of partition elimination, and you have to scan through each and every partition, and that's gonna slow down your queries. In our case, we did not see that. Maybe that's because we have a fewer number of files, but in reality on a production environment with a production table where you have partition configured, and if you have this kind of an scenario where your most of your queries are basically using a non-partition column, or any queries that is going to use a non-partition column is going to suffer on the performance front. In that case, what you need to do is like you will basically have to recreate that table with a different partition column. Yeah. And when you do that, what happens is like the whole thing gets rewritten. Yeah. So right now, all the partitions that we have is on the transaction date, and the data is written based on the transaction date because that's the partition column. Now, if you want to change that to a different column, it's going to be a complete rework where Databricks has to change this, and then it has to basically create new folders based on the partition column, the new partition column. That's going to be a huge work. So that's the reason it's critical that you understand your business logic and make sure like you are selecting the best partition column. Now the thing is like selecting the partition column is more of an trial and error basis wherein you will try different partition columns and then come to a conclusion like one particular column seems to be good. It can't be the best because you cannot 100% confirm like the partition column would be the one that will be placed in the predicate. That's going to be a problem. Yeah. So in that case, what you need to do is like you need to come to a conclusion of selecting the best good partition column that may be like try satisfying maybe like more percentage of the queries that uses the predicate as that particular partition column. That's one disadvantage as far as the partitioning is concerned, because on a demo you can run all the queries on the partition column as far as the predicate is concerned, but in reality in a production that's not possible because in production based on your business logic things changes and predicates as well changes, and that's going to be a big problem. So that's something that you need to keep in mind. But other than that, if you select the proper partition column, I think partitioned concept is really, really going to help you in bettering or improving your query performance to a greater extent in Databricks. I hope you like this video. Thanks for watching. Have a great day. Jai Hind.